In Chapter 16, we're going to take a closer look at sampling. And we use sampling all the time in Statistics 100. So when you take your exam and you turn it into us, it takes us hours and hours with about 20 graders to go through all 1,200 exams. But your lecturer wants to know how the class is doing beforehand. She doesn't want to have to wait till the very last exam is graded to get a feel for how the class has done. So what we utilize is sampling. We take a small sample out of those 1,200 students to try and gauge for the feel of the class grade as a whole. So there are a couple ways that we could go about doing this. We could just take the top 50 exams in each folder, which those are the last students to turn in their exam. We could grade the 50 exams of students who are begging us to grade their exams because they're not sure if they want to drop the class or not. They're not sure if their grade is going to make the cut. Or we could just grade, the A folder with last names of A or the last names of Z, something very specific. We could look at the kids who sit in the front row. We could look at the kids who sit in the back row. There's lots of ways to grab a sample. But which sample is going to give us the most reliable representation of the Statistics 100 course as a whole, of all the population? So, you're going to remember this great R word that we've been using through every chapter of this course. Randomization. There is nothing like it. Randomization eliminates human bias. It is able to give us this general feel, a great sample, a great even distribution, a sample of some of the best, some of the worst, some of the average, so that we're able to get a good feel as a whole of this gigantic population that takes us hours to sort through. So we randomly select about 50 exams out of the 1,200, and sure enough, our sample gives us an excellent indication of how the class as a whole is going to do. So that's what Stat 100 does. And guess what? This is used nationwide in politics, in news, in current events, and everything from science to everyday, the opinion polls online, right? So we are going to take a look at sampling so that you can identify which surveys are reliable, who to trust and who not to trust. If you turn on the news, one of the hottest topics is Congress's approval rating right now. So we have 200 million adults in America, right? And I'm sure that every one of them has an opinion about Congress. Do we approve? Do we disapprove? But are we going to be able to call every single one of these 200 million adults to be able to get their opinion personally on Congress? No, that's just not feasible. So we need to utilize sampling. And there are lots of surveys going around with lots of different numbers being thrown around. So for right now in front of us, I have two surveys that ask the exact same question. It asked Americans whether or not you approve or disapprove of the job that Democrats are doing in Congress. These two surveys were asked almost in identical wording. Now, who they asked and how they asked was a little bit different. The first survey is a Newsweek poll where they asked just over 1,000 American adults randomly. So they had this big box of every American opinion, stirred it up really well, and randomly picked out 1,000 Americans about. And they found that 41% approved, 47% disapproved, and 12% were unsure. Now let's look at another survey. This is Iron Mill News, and this was an online survey where anybody with access to the internet who cared enough could go online and share their opinion with the world. And they found that 25% of these online voters approved, 75% disapproved, and nobody was unsure. So, the same question, different results. Who is more reliable? So the number one thing that we want to look at is how this survey data was collected. And remember, randomization is the best way to go to be able to get the best representation of the American public as possible. So rather than looking at only people with internet access who care enough to go online and want to share their opinion with the world, these are probably people who are very opinionated and feel very strongly either way. That seems to be kind of a biased survey result, right? This is one pocket of America that feels strongly enough to go online and vote. Now over here, this was people who, with opinions in either direction, and people who weren't really quite sure. This was a sample of America as a whole. So we would say that the Newsweek survey, just based on how it was collected, is a more reliable indicator of how the American public feels as a whole. And you'll notice that the size of the survey really isn't what matters. Even though that Iron Mill had more individuals, some people would think, oh, the more people you survey, the better. That's not necessarily true. It's about how you get those people to survey, how you select them to survey. So we were able to get a nice random sample, an even representation of America, from the very wealthy to the very poor, to the educated to the uneducated. This was assumed to be an unbiased random sample. Well, this was just people with a lot of, fury at a mouse on a computer who had enough opinion to go online and vote. The second major advantage to a randomized survey is that we're able to apply the statistics we've been using all year to them. So you'll notice that this Newsweek survey, they reported a margin of error of plus or minus 3% for each of their results. So what this really means is Newsweek understood that they had all of these American adults' opinions in a box. And they randomly sampled, just like we have been doing in our class, randomly sampled each of the tickets out of the box. So we were able to come up with this margin of error, which is really plus or minus 2 standard errors. That's all that is, 2 standard errors. Just because this is using our box model. And we're able to use these statistics that we've been using all year long to analyze this data. Now, over here, no margin of error was reported. And this is because if America was in a box, right, with all these tickets, these were the people who were asking to get out of the box. These were the tickets that were self-selecting to jump out of the box themselves, rather than being, randomly selected. So, because this was not randomly taken, we can't really use this as a scientific experiment, and we can't apply these statistics to it. So once we've collected a sample, who does that sample really apply to? Which population can we infer the same results to? Well, let's take a look. Let's say that I conducted a survey in Champaign-Urbana where I randomly selected 250 U of I students, and I asked them, do you skip breakfast? And 38% of them skip breakfast. Now, when I go to write up this survey and I go to, write up the importance of eating a good breakfast and I report these results, who can I report that this 38% is skipping breakfast? So let's look at a few examples of where can I apply this survey result. So, can I apply this? So let's just, say here was my box of the U of I students, right? And I randomly selected 250 U of I students. There's my box. That's the population that I sampled from. Can I apply this 38% to Statistics 100 students, which really is just one pocket inside of U of I? Here's the Stat 100 population. It's a subset inside of the U of I population. And the answer is no. That if I had truly randomly selected U of I students, that this Stat 100 population is far too specific based on the population that I had sampled from. So the answer is no. We could not apply this to Stat 100 students. If I wanted to get a feel for what percentage of Stat 100 students were skipping breakfast, I'd have to ask a random sample of Stat 100 students. You can't go more specific than the population you sampled. Yes?
Is that because Stat 100 students might not be like a really good cross-section of all U of I students, because maybe we don't have many engineering students, we don't have...
Exactly. Stat 100, when you look at Stat 100, it's a big class and it does contain a lot of students, but when you look at U of I as a whole, U of I as a whole is much broader than Stat 100. For instance, business students often don't have to take Stat 100. They have a very specific business statistics course that they take. So this blue sample doesn't contain any of the business students that may have been inside of my orange sample. It might contain, a different proportion of, students who are from rural areas or city areas, or it might contain more seniors or freshmen, something like that. Well, the U of I student was just student base was a more broad representation of U of I as a whole. Yes.
Oh, yeah, and it has many more girls, like the U of I is probably about 50-50, but
Exactly. We find that our survey data, we have a lot of females in Statistics 100, way more than half, while the U of I population is roughly 50-50. So because the Stat 100 population is actually quite different from the broad U of I student population, this is much too specific, it's too different from the population that I selected from. I cannot directly apply this 38% to the Stat 100 student population because the two populations are just too different. So let's take a look at the next one. Can I jump to the conclusion that 38% of American adults skip breakfast? And where would American adults be on this one? It would probably be a huge box, right? If these are all of the American adults, USA adults, U of I students are just a really small fraction of U of I adults, right? There are adults in Florida to Alaska. There are adults who are 65 years old to, who just turned 18. U of I students are just a very small pocket. So U of I students are not a fair representation of America as a whole. So I can't use my survey of U of I students to represent something that's bigger and broader than the U of I students. So this one I would say, no, American adults is too broad of a group for me to apply my limited population to. The next one, U of I athletes. Well, U of I athletes is probably going to be something like this. It's a small elite group of athletes who are able to compete at a D1 level. So I have my athletes right here. And athletes, is that really, are U of I students and U of I athletes really the same thing? No. That U of I students as a whole, that contains a much broader spectrum than just these, elite physical specimens that are able to compete so well at a college level. Athletes and U of I students are two distinct populations. So these athletes are really just a subset inside of U of I, and it's too specific for me to apply this 38% to. I would say that very few athletes skip breakfast. They probably, more than anybody, would understand the importance of a good, healthy breakfast before they perform each day, right? So no, athletes, that's too specific compared to the population that I sampled from. How about college students nationwide? And again, we're probably going to see, maybe something like this, a box like this large. We're now in the blue. Here are college students. And U of I is just one college out of many, right? And different college campuses have different feels. Some are more conservative, some are more liberal, some are in the north, some are in the south, some are, geared towards engineering, some are geared towards, liberal arts. So U of I is not going to give us a fair representation of colleges nationwide. So college students nationwide is too broad. So the take-home message here is that the only place that you can apply your survey data to is directly to the population that you surveyed it from. You can't go any bigger, you can't go any smaller. You have to go just right, just in that population.